Good evening, guys. It's me, Rajkiran. On behalf of School of AI Trivandrum, I welcome you all to the day 11 of Python Study Group. Let us have an overview of last session, that is week 5, part 2. In the last session, we have learned decorators and generators. We have learned how to create, how to use both. You can get this presentation by going to the following link: SOAI hyphen python hyphen week 6 hyphen 1. I repeat, tiny.cc slash SOAI hyphen python hyphen week 6 hyphen 1. As always, don't hesitate to ask any questions. You can use the chat panel in YouTube during the live session, or you can ask your doubts in Discord channel or the WhatsApp group that we have provided you. I'm happy to say that we have completed all the basics of Python. From week 6 onwards, whatever we are learning are additional contents. So in this part 1 of week 6, we will look at the built-in modules that are logging, collections, and PDB. So let's start. I request everyone to open your Colab notebook and start coding with me. Okay, I have just created a new Python 3 notebook and I have already built in some contents, written some contents in this notebook. What I will do in this session is walk you through all these modules, that is logging, collections, and PDB. So, what are built-in modules? You can see that when we do import logging, this statement works. So, logging is actually a module or a package that is already been built in into Python. There are some packages that is not built in, but you can have that packages using pip install. We have learned that in our previous lesson. Okay, I will show you list of modules that is available. Just this is the statement that I am running. Okay. I just opened a Python terminal and typed help in single quotes modules. You don't need to do this. I'm just showing you that these are all the inbuilt modules that is available in Python. So we will not have an like time to go through all of this, but I will show you some of the things that are being used like frequently. Okay, let's jump back to the notebook. Okay, so I'll start off with logging. Logging is a very useful tool that every Python developer should know. It helps you to understand the flow of program and discover different scenarios while developing. It helps you to debug your program as well as know what is happening when a program is run. Using logging in rightful places with rightful data will help us not only find errors but also to analyze the performance of the application. What you are seeing here is actually the original documentation of logging. You can get this link by just going to Google and typing Python 3 logging. And see, the first link itself will be the how-tos or the logging module. So this is that link. Okay. So to start off with, in logging module, there is a concept called levels. There are 5 levels, that is debug, info, warning, error, and critical. This is actually the order of priority. Debug has the lowest priority, followed by info, warning, error, and critical. So why are we setting these levels? Okay. For example, logging module by default sets level to warning. Okay, which means that anything that is below this level, that is called info and debug. Anything that is below this warning will not be logged. Okay, so you can actually set levels in your Python program. For example, you can have all these levels, but in your console, if you only want to see errors, you can set the level to error. So all these log information like debug, info, warning, etc. will not be shown. Now I am going to run this line of code. I'm importing logging and logging.debug, info, warning, error, critical. These are all the different methods that is available in this logging module. So this is the message that I am going to print. This is a debug message, this is an info message, this is a warning message, and so on. So if we run this cell, we will have an output like this. Okay, this shows that logging module, as I have said, by default set the logging level as warning. So anything below that level will never be logged, which sees that we can see that debug and info is not seen in the output. Debug and info is not being seen in this output. Okay, I will just run this cell for you. See, this is because by default logging has a level of warning. So level equal to warning and greater than warning will only be logged. So this is what we are seeing. This is actually the format that you are seeing in the console. So by default the format is level, that is warning, then followed by name. Here the name is root logger, then followed by the message. This is the message, right? All this will be separated by colon. This is the default format in which the logging is being done to your console. Now let us look at the basic config. So whenever you call this thing debug, info, warning, logger, etc., it actually calls this function first, that is basic config. It will be only executed once. So in basic config, you can set logging equal to debug, and you should see all these messages. But if I try to run this, now you will only see warning and warning, error, and critical. Even if we have set the level as debug. Okay, now using the basic config, now we can set the level. We can override the default level. That is, the default level was warning. Now I am overriding that to debug. I want everything to be shown from the level debug. So that was not working. Why? Because when you imported this thing, it actually ran this function basic config, and at that time the level was set as warning. So if you try to run this cell again, this will not set that level. It will only take in the default level. So for that, you should actually do this first in your program code. To make this cell running, I'm going to restart my runtime. Okay. Control plus M that and followed by dot. Okay. So this is the shortcut that I will be using. So when you restart, you can see restarting, initializing, and it is done. So now when you run this, now you can see all this information. So in this entire session of like logging, you might want to actually go in and restart your runtime. Okay, what I will be doing is using the shortcut Control M and dot. Okay, there are different parameters that can be passed into the basic config. So this is actually Python documentation that says what are the arguments that is being used in the basic config. Okay, there is file name, format, file mode, format, all these things, right? File name allows us to write to a file, write logs to a file. We have already seen the use of level, that is to set the level of logging. Okay, format is we can actually change the string that is being displayed when logging, and we can change that by using the format argument. Okay, I'll walk you through that. Okay, just to recap, this exclamation actually runs terminal commands. So currently if I run this, I will have like sample data. I don't have any other files. So what I am trying to do here is create a file called app.log with a file mode called write. So there is also a file mode called A, that is append. What A will do is it will keep whatever content that is already existing in this file and append to the end of that file. So when you are using W, it will actually start writing as a new file. Okay, so the previous content will be lost. And now I am specifying the format as name, level name, and message. Okay, and then I am going to do logging.warning. So before I do, I am going to restart myself notebook. I am restarting my notebook and I'm going to run this. Okay, now when we do ls, we can see that a app.log file is being created. And when we try to see what is inside that file using the cat, you can see that it has root, warning. This is, see, the default string was like level, name, followed by message, and in between there was colon. We have changed that behavior to see name, level, and message, and in between it has like a hyphen. See, this way you can actually write logs into your file. Okay, you can actually change the format into whatever you want. There is also a date format in which you can get output like this. See, now I am only formatting like the date and time followed by message. So I am only having date and time followed by message. Okay. Now, before I go into that, I could to show you one more thing. Okay, go to this thing. This is mm, maybe this. Yep. Okay. This is actual documentation. These are the different attribute name that you can use for formatting. What we had just used was like AC, AC, ASC time. Then what else we have used? We have used message. We have used name, and all this attribute name can be used while you format. This is available in the documentation of Python. Okay. Everyone, please go to this site, realpython.com. This is actually a good site that I will recommend. It has amazing like blogs and articles where you can go through. I have actually prepared this content by using this content, logging in Python 3. Okay. Okay. So once again, realpython.com. Okay, that is the website that you have to go to. Closing all this thing. Coming back. Now we just looked at how to format output. Now, logging variable data. You can actually use other variables inside this message. All you need to do is format the string. This is what we have already learned. Use F and followed by braces and the variable that you need to add. So here you can see that the variable name is replaced in this message as John raised an error. Okay. One thing to note that you might want to restart the cell. Control M dot. Yes. Starting and then run this cell. So okay. Now let's run this. How to capture the trace. Trace is what has happened. Like in the cell, when we are trying to catch an exception, we are trying to divide a by b, which is actually 0. So we will have a 0 division error here. So we are catching that and logging error as exception occurred. Now we only have this message being logged. We actually don't have where the error has actually occurred. That is, the traceback is not available. For that, what you can do is pass in an additional argument called exe underscore info equal to true. Okay, by default that is false. So you can make that to true and then run this again. Now you can see that now you will have exception occurred followed by a traceback, that is the error occurred at this line, that is c equal to a divided by b, and that error was 0 division error. So all this information can be logged. So this is like a common practice where you whenever you do error, you have to actually like do exe underscore info equal to true. So what the Python community has done is that they have added an additional method called as exception, in which this x underscore info is by default true. So you can actually use exception and without any parameter. Okay, this is actually equal to this line, but just to keep in mind that there is also a method called exception where you don't have to actually pass in those argument. Now these are the commonly available classes inside logging: logger, log record, handler, and format. Okay, logger is something that we will be using. Log record is actually all the details that is we have just seen: name, ASC time, message, etc. Handler is whenever a log message is being made, you can add handlers like a handler to send to console or a handler to write to file and so on. These are some of the handlers available: stream handler, file handler, SMTP handler, HTTP handler, and so on. Formatter is what we have just seen, which helps us to format the output string. inside logging. Now let us look at handler. Okay, what I have done here, this is just to show that there is nothing here. What I have done here is that I have created a logger using the function get logger, and you can pass in any name. Say my logger. Okay. Then I am going to create two handlers. One is a stream handler, which will write the output to my console, and another is a file handler that will write the log into this file, that is file.log. The advantage of this handler is that we can actually specify different levels for different handlers. For the console handler, I am going to set the level as warning, and for file handlers, I am going to set the error level as error. So what this means is that only messages that has level warning or above will be shown to the console, and only messages or logs that has an level of error or above will be written to a file. We can actually specify two different formats for these two different handlers. Okay, I am setting those formats here, and finally adding these two handlers to the original logger using add handler. So when I do logger.warning, since warning we have set console level as warning, we will see everything above warning. So we can see warning and error in the console itself. That is what you are seeing here. Okay, we have formatted this as name, level, and message. Okay, but since we have set file handler as error, this warning will not go into that file. We can see that when we cat the file, only the error message is being copied or written into the file. That actually has a different format. That is a format time, name, level, name, and message. Time, name, level, name, and message. This is what everything about logging. Okay. Now let us look at another module called as collection. You can actually see the main thing by replacing this by collection, and you will have the main documentation. See, this is the main documentation. Going back, opening the collections. Okay, collection module has some inbuilt methods: name, tuple, dequeue, chain, counter, order, dish. We will be only looking at some of the things that is important. So let's start with counter. Counter is a function in collection module that takes an iterable and returns a dictionary. For example, I am just for restarting. Okay. Okay, I am going to run this. And from collections module, I'm going to import counter. Okay, and I have a list which has many elements, and I am going to pass this list into my counter class and create an object out of that. Okay, so when I like cnd is the variable or the object name. So when I do cnd in square bracket 1, what it will actually return is the number of occurrence of the element 1 in this object. You can see that there are 3 ones. See, 1, 1, and 1. We can actually get the elements in sorted order by using elements. The other advantage of counter is that rather than creating a list like this, you can actually do something a sort of dictionary way. You can say that 1 repeats 3 times, that is 1:3. 2 repeats 4 times, that is 2:4. So when you run this elements is actually iterable. So in order to see that, you actually need to change the type to list. So I'm changing that type to list and printing this. So I can see that 1 is repeating 3 times, 2 is repeating 4 times. I can also get the most common elements inside this list using the most common function inside that object, method inside that object. We can see that 1 is the most common and it is being repeated 3 times, followed by 2 repeating 2 times, 3 repeating 2 times, 1 is only occurring once, 6 is only occurring once, and this is the list that we get as return. There is also a method called subtract, in which there is like one dictionary is being created as an object. I can subtract the number of elements that is occurring. If I want to like delete 1, that is one time available, and 2, that is 2 times, I can subtract and pass this dictionary, and what I will get as return is there was actually 4 repetition of 2. I have reduced 2 repetitions, so I am only having 2 colon 2, and in there was 3 repetitions of 1. I am reducing that to, I'm reducing 1 from that, so I will get 2. So this is the use of count. Now let us look at default dict. Okay, the default dict works exactly like the dictionary in Python, except that it will not throw a key error. Okay, I will show you what I meant by that. See, I am creating a dictionary and I have 2 keys, one as with a value 1, 2 with a value 2. So when I try to print num with a key 3, we have only assigned 1 and 2. There is no key called 3. So this will raise a key error saying that the key 3 is not present. So in order to avoid this rising of an error, what you can make use of is the default dict. Okay, using the default dict, and you can pass in what should be the behavior. I am saying that my default dict should return 0 whenever there is, let's say, whenever there is a key error. So if we run this, we can see that whenever there is a key error, this call returns a value of 0. We can actually pass in a callable object here, which means a function. See, I am creating a function. You can name it anything and use that name here. I'm just using CC, and I'm returning true. So whenever you have something, it will return true. You can actually change that to like false. See? So whenever there is nothing, it will return false. You can have anything here. So this is something that you might need in your development. This is something main that you will eventually come across. Default dict. Now that is everything about collections and logging. The final thing that we will be looking today is PDB. Debugging programs can actually be a tough task. You don't know where like what went wrong. Like find it easy. That is the correct word. You will not find it easy. So in that scenario, we can make use of the module called PDB. Okay. I have an example here. Import PDB. And what we can do is set trace is a method. You can add multiple traces. A trace is actually similar to adding a breakpoint. So whenever this function is called, your execution will break here and will provide you an interface for actually running some commands. So pdb.setTrace will actually add in some breakpoints which will help you to run some commands. So what all commands can we use? I'm just opening this link. Okay, so these are the commands that is available in the original documentation of Python. It's W, D, U, B. There are many commands. We'll be only looking at some of the commands that is commonly be used. Okay, I'm going to run this. So this is what you get as output. See, I have a function called add and symbol function, and then the beginning of function I have set a trace, and here also I have set a trace. You can use this ll command to actually tell you which is the next line that your code is being waiting. See, your code is being waiting to run this cell. So if you currently check in var, you can see that there is name error. Okay, because this line has not been executed. It is waiting to execute this line. This is the advantage of this PDB. You can add in breakpoints in your code so that you don't actually need to go in and uh, okay, for example, what as a fresher, what I used to do was I didn't know about PDB. So what I used to do was I will go in and actually print like var here so that I will know what was the value of var during the debugging. So this can be actually avoided, right? So you just need to add the breakpoint so that this can be seen. Okay, I have shown you LL, that is this thing. LL actually shows you a full line number code, source code. Okay, then followed by N. N is actually the next. It tells the pointer to move from here to here, the next line. So it will execute this line and move to the second line. So when I type in N, see now the head is at this print one line, which means that the var was already executed. So now when you type var, you can see it has a value of N. Okay. Now what you can actually do is, see, this function was already defined. So actually you can call this function also. You can check if this function works. You can add 1 comma 2. This was, I'm actually calling that function here. When you are doing some code here, it doesn't affect the original code. It is only for debugging purpose. So I have talked about command ll, the command n. Now you have a command called utl, that is until. You can run this line until it reaches, let's say 30. So let me just go back and see it is utl. Sorry, it was unt. Okay, going back, unt 30. Okay, see, now what it has done is it has actually executed all this thing, and now it is waiting at line 30. So if you don't want to execute everything, you can actually jump to 30. Now that is using the keyword j or the command j. Okay, in order to quit, you can actually use q. Okay, it quits. Okay, I'm going to run this again. Okay, now it is waiting at this breakpoint. What if you have to execute everything that is inside the second breakpoint until the second breakpoint? You can use continue, that is C. So what it will do is execute all the lines and it will execute till Another breakpoint is C. So see when you type the command C, it will actually go and run this out, and it will wait at this line. It will execute this and see that this is a breakpoint, and it will wait us at print 3 line 3. Okay, which means that now when you type out, you should have that value 50. Okay, 5 divided by var, which was, let's say, what was var? So you can see that var was 10, and 5 and var was returning 15, which is working 5. So this is how you actually do the traceback. We have learned about, you can type in n and see that it is next is return. You can press C to stop everything. This is how you make use of PDB. So these are the some of the commonly used commands, that is N, C, Q, LL, J, UNT, etc. You can go to this document for seeing additional things. Okay, that's it, guys. As a wrap up, we have looked at logging, how to create custom handlers in logging. We have also learned some of the modules in collection, that is default dict as well as counter. Then we have looked at PDB, which is like one of the important thing that you should know for debugging a code. So that's it, guys. Thank you for attending or watching this today's session. You have done a great job. You can ask any questions if you have. You can make use of the chat panel or make use of the WhatsApp or Discord channel. Thank you, guys.